Okay, the next thing that we're going to talk about is something called multiplicity. This might be something that you've never heard of before, but don't worry, it's pretty easy to figure out. We're dealing with something called repeated roots. Roots is another name for zeros or factors. They're all the same depending on how you look at them. And repeated means that it happens more than once. So multiplicity is looking at the number of multiples of that root or zero or factor, which means we're looking at the exponent of that factor. Okay, so multiplicity is tied into the exponent. So if we have something like f of x equals x squared times x plus 2. Okay, x squared times x plus 2. All right, so we know what the zeros are from the last video. And let's see if we can figure out the multiplicity. Multiplicity, lots of I's. Okay, so the zeros for the first one, when we have x by itself, we know that we get x equals 0. And from x plus 2, we know that we get, oh, let me space this out a little bit more. We know that we get negative 2. Okay, so our zeros are 0 and negative 2. Now, what is the multiplicity? The multiplicity is the number of times that that root repeats. So in other words, it's the exponent. So for 0, our multiplicity is the exponent right here. Our multiplicity is 2. So our 0 at 0, we get multiplicity 2. And at negative 2, our multiplicity is the exponent right here, and whenever there's no exponent, it's implied to be a 1. So our multiplicity for negative 2 is 1. Okay, so we get our zeros just like we did before, looking at the factors. And our multiplicity comes from the exponent on that factor. Now, when you talk about multiplicity, it has to go with a 0. It doesn't make sense to just talk about multiplicity 2. You have to say 0 with multiplicity 2, negative 2 with multiplicity 1. Okay, so they have to go with the 0. Now, what does this matter? Why do we care? That's always a good question to ask. Let's look at the graph for this and see if we can make the connection. So what this graph is going to look like, let's see if I can fix that a little bit. All right, this graph looks like this. Okay, we can see the zeros at, so I can draw these in. Okay, so we've got our zeros at 0 and negative 2. Okay, so those are our zeros. And let's look at what happens with the multiplicity. Okay, let's start with negative 2. At negative 2, we have multiplicity 1. And what happens is when you zoom in really far, if you have a 0 of odd multiplicity, okay, so 0 of odd multiplicity, what happens when you zoom in near that 0, it's going to look like its power function. So if you've got odd multiplicity, it's going to look like an odd power function when you get really, really close to that 0, which means that the graph is going to pass through. So when you have a 0 of odd multiplicity, the graph passes through. Okay, so you can think of that like x or x cubed. The graph passes through. When you get close to a 0 of even multiplicity, my pen's jumping around a little bit. Hold on, guys. Let's see if I can fix it. Okay. A 0 of even multiplicity, okay, at a 0 of even multiplicity, that's right here. When we get in really, really close, what does that look like? It looks like a parabola. Okay, so when we get close to a 0 of even multiplicity, it looks like an even power function, and we know that even power functions look like parabolas. So the graph is going to turn. Okay, so if you're near a 0 of odd multiplicity, it passes through. An even multiplicity, we say that it turns. It touches it and then turns away, just like a parabola does. Okay, so even multiplicity, think of a parabola, and odd multiplicity, think of x cubed. All right, so let's see if we can predict the behavior of a graph just by looking at its factors. All right, so let's say that we have f of x equals x minus 2 squared, x plus 3. Okay, so we want to look at zeros and multiplicity. Okay, so what are our zeros? Remember, zeros come from the factors. So here we've got 0. Here we've got positive 2. We've got positive 2. And then here we've got negative 3. Okay, so 0, positive 2, negative 3, we get those from the factors. Now, what is the multiplicity? Remember, we look at the exponents. So for 0, we've got an exponent of 1. At 2, we've got an exponent of 2. And at negative 3, we've got an exponent of 1 again. Okay, so what is going to happen with the graph? At 0, the multiplicity is 1, and that's odd, which means the graph is going to pass through. At 2, the multiplicity is 2, that's even, so that means that it's going to turn. And in negative 3, the multiplicity is 1, that's odd again, and so the graph is going to pass through. Okay, so we know what the zeros are, we know that what the graph is going to do at each of those zeros. Now let's look at the graph and see if we can match it up. So what this graph ends up looking like, give me a second to draw it out, it looks like this. Okay, it kind of looks like a warped W. All right, and let's see if we can match up what's going on here. So we've got zeros at 0, 2, and negative 3, so that matches what we were expecting. At 0, we want to go through. You can see that the graph goes through. At 2, the graph is going to turn. You can see that little parabola shape there, it turns. And at negative 3, it needs to go through. And it does. Okay, so now we can tie in the factors and the exponents to what's happening on the graph as well.